Okay, welcome back. This is Mathematics 9 and your teacher, Gemma P. Coronel. How are you, everybody? Good morning sa inyong lahat. Our lesson for today is about Module 1, Lesson 2A, Solving Quadratic Equation by Extracting the Square Root. Okay. Now, we have 4 ways in solving quadratic equation. Number 1 is by extracting the square root. The second is by factoring. The third one is completing the square. And number 4 is quadratic formula. And our lesson is solving quadratic equation by extracting square root. Now, let us review first the standard form of quadratic equation. The standard form of quadratic equation is written in ax squared plus bx plus c is equal to 0. A should not equal to 0. And what is A? A is a numerical coefficient of x squared, or it is known as a quadratic term. B, x is a linear term, and b is the numerical coefficient of x. And c is the constant number. Now, example. For the first equation, ax squared plus bx plus c is equal to 0. It is x squared plus 3x plus 2 is equal to 0. A is 1, B is 3, and C is equal to 2. Now, another form, ax squared plus bx is equal to 0. This one is a standard form of quadratic equation also, where C is equal to 0. As you notice, nawala po ang C. Now, again, the example is 2x squared plus 4x is equal to 0. The value of A is 2, and the value of B is equal to 4. C is equal to 0. Now, the last one, ax squared plus c is equal to 0. This is also a quadratic form or a quadratic equation where b is equal to 0. Example, 2x squared minus 73 is equal to 0. And then we have to rewrite this in the form of ax squared plus c is equal to 0. Okay? Using axiom of addition, add both sides 72 in both sides of the equation. 2x squared plus minus 72 plus 72 is equal to 72. Okay? Then divide both sides by 2. The resulting equation is x squared is equal to 36. Why? Because 72 divided by 2 is 36. 2x squared divided by 2 is x squared. That's why the final answer in this equation is x squared is equal to 36. This is also written in quadratic equation. Okay. Quadratic equation that can be written in the form of x squared is equal to k and can be solved by extracting the square root. Again, quadratic equation can be written in the form of x squared is equal to k. K here is constant and can be solved by extracting square root. Next, we have to consider the different properties. For number 1, if k is equal to 0, the constant number k, then x squared is equal to k has two real solution or root. X is equal to positive, negative square root of k. Take note, if k is greater than 0, has two real solutions or roots. Number two property, if k is equal to 0, then x squared is equal to k has one real solution or root. X is equal to 0. Again, if k is equal to 0, the constant number, then x squared is equal to k has one real solution or root. X is equal to 0. Number 3, if k is less than 0, then x squared is equal to k has no real solution or root. Again, if k, the constant number k, is less than 0, mean to say that the value of k is negative because that is less than 0, then x is equal to k has no real solution or root. Okay? Now, example number 1. Find the solution of the equation x squared minus 16 is equal to 0 by extracting square root. Solution, x squared minus 16 is equal to 0. We have, again, write the equation in the form of x squared is equal to k. Using axiom of addition, mean to say that you have to add 16 on both sides of the equation. The resulting equation, x squared is equal to 16. Then, since k is equal to 16, it is greater than 0. Then the first property can be applied. And what is the first property? You have two solutions or roots. Let us see if that is correct. Extract k. Extracting square root, square both sides of the equation. If we say extract the square root, square both sides of the equation, then the square root of x squared, and that is a perfect square, is x, and the square root of 16 is positive and negative 4. Why is it positive and negative 4? Because 4 times 4 is 16. Negative 4 times negative 4 is equal to 16 also. That's why we have two solutions or roots. X sub 1 is equal to 4. Another value, x sub 2, is negative 4. We have two real solutions or roots. Take note, if the question is you have to find the solution, we are after with the value of x. If the question is find the roots, that is the same. We have to find the value of x. Or find the value of x, it is also the same. We have to find the value of x. Again, find the solution, find the roots, find the value of x. It is expressed in different way, but the solution is the same. Okay? Number 2, solve the equation t squared is equal to 0. Now, take a look with the direction. Solve the equation. Solve the equation. The first example, find the solution, but we have the same procedure. Okay? Now, solution, t squared is equal to 0. Since k is equal to 0, the second property, then the equation has one solution or root. Square both sides of the equation. The square root of t squared is equal to 0. The square root of t squared is t, and the square root of 0 is equal to 0. Therefore, t is equal to 0. Now, let us go now to example number 3. Again, since t is equal to 0, one solution or root. Okay, number 3. Find the roots of the equation x squared plus 9 is equal to 0. Now, we have the solution. The first thing we do is we have to write the given equation in the form of x squared is equal to k. X squared is equal to negative 9. Then, square both sides of the equation by subtracting the square root. We have to square both sides of the equation. The square root of x squared is equal to x. And the square root of 9, a perfect square, cannot be negative. Now, since k here is equal to negative 9, and k is less than 0, then the equation has no real solution or root because a perfect square cannot be negative. Again, k here is negative 9, as you notice. K is negative 9. Since 9 is less than 0, then the equation has no real solution or root. The third property is applied here. Okay? Yan. X is equal to square root of negative 9. No real solution or root. Again, a perfect square cannot be negative. Therefore, no solution or root. Now, example number 4. Find the solution of the equation x minus 4 quantity square minus 25 is equal to 0. Okay. Again, write the equation in the form of x squared is equal to k. That is x minus 4 quantity square is equal to 25. Okay, since x squared minus 4 is expressed in square, we have to square both sides of the equation. That is by extracting square root. Okay, but here k is equal to 25. Since 25 is greater than 0, then the first property can be applied. Again, here, 25. This is considered as k. K is equal to 25. Since 25 is greater than 0, then the first property can be applied. And what is that first property? We have two real solution or root. By extracting square root, square both sides of the equation. The square root of x minus 4 quantity square and the square root of 25. Again, the square root of x squared, the square root of x minus 4 quantity squared is equal to x minus 4. And the square root of 25 is positive and negative 5. Why? 5 times 5 is 25. Negative 5 times negative 5 is also 25. Then, solve for x. X is equal to 4 plus 5. And the other one, x is equal to 4 minus 5. X sub 1 is equal to 9. X sub 2 is equal to negative 1. We have two real solutions or root. Okay, now this is your activity. Extract note. Direction. Solve the following quadratic equation by extracting square root. Answer the question that follows. But I have to consider 6 and 7 again as your example. Okay, you can take picture if you want doing this exercise. Okay, let us continue for number question. How did you find the solution of each equation? Letter B. What mathematical concept and principle did you apply in finding the solution? Explain how you apply this. Again, as what I've said, I have to consider 6 and 7 as your example. Another example. Number 6, 4x squared minus 225 is equal to 0. Then 4x squared is equal to 225. Extracting the square root, the square both sides of the equation. Since 4 is a perfect square, x squared is also a perfect square, and 225 is also a perfect square, we can simplify. The square root of 4 is 2. The square root of x squared is x. And the square root of 225 is positive and negative 25. Then, since the numerical coefficient of x is 2, and we are after with just value of x or the root. Again, the roots is the value of x. Since here, the numerical coefficient of x is 2, we have to eliminate the value of 2. Divide both sides by 2 in order to get the value of x. 2x divided by 2 is x. 15, positive and negative 15 divided by 2 is positive and negative 15 over 2. We have two solutions. X sub 1 is equal to 15 over 2, and the x sub 2 is equal to negative 15 over 2. Yan. This is the procedure. Again, the k here is equal to 225. Since 225 is greater than 0, then the equation has two solutions or roots. See to it that the property is congruent to your answer. Okay? We have two real solutions or roots. Now, for the last example, we have number 7. As what I said, I give you another example. The number 7, I consider number 7 as your example. We have 3h squared minus 147 is equal to 0. Write the equation in the form of x squared is equal to k. Now, we have 3h squared is equal to 147. Since 3 here is not a perfect square, we have to divide both sides of the equation by 3. Again, the numerical coefficient of h squared is 3. Since 3 here is not a perfect square, we have to eliminate. Divide both sides by 3. Okay? Then, divide both sides by 3. 3h squared divided by 3 is equal to h squared, and 147 divided by 3 is equal to 45. Then squared both sides. The square root of h squared is h, and the square root of 49 is positive and negative 7. Since k here is 49, since 49 is greater than 0, then the equation has two solutions or roots. 8 sub 1 is equal to 7. 8 sub 2 is equal to negative 7. Is that clear, class? Okay. We have two real solutions or roots. Again, if the question is find the solution, find the roots, solve the following quadratic equation, we have to solve for x. Is that clear? Again, this is your activity. Number 1, number 2, number 3, number 4, number 5, number 8, number 9, and number 10. See you guys. Thank you. Keep safe. See you next meeting.